So we're just going to go over all these problems to make sure we get them right. Here we have a graph that we're going to graph, and we're going to see the numbers of what each one does. Just remember, absolute values, when we graph them, make V shapes. Okay? So here we have a slope, and this is our X movement, and its opposite. So that's going to go left 2. And then this is the Y movement. And it's going to go down 4. So we have our V shape that we're going to make. It's going to go left 2, down 4. That's our vertex. Then our slope is -1/2. So we're going to go down 1/2. Down 1/2. We have that V shape right there. No x-intercepts. We do have a y-intercept though. We have a vertex. Next, we're going to do the same thing for number 2. This isn't a slope. This tells us that it's going to open up. And it's going to be twice as tall. This is going to be a right 3 because it's the X movement. This is up 5. And this is a squared here, so it's not going to be a U shape. It's going to be U shape. It's not going to be a V shape. I'm saying it's going to be parabola. So we're going right 3, up 5. That's our graph so far, right there. Now we know it's a U shape. We have the axis of symmetry. And what we're going to do now is we need to find another point. So I'm going to put a 0 in and solve, and it's going to tell us the rest of our graph here. So we got 2, 0 minus 3 squared plus 5. We get 2 times 9 plus 5, because 3 squared is 9. That's 18, so 23. This is a y. So that we have a 23 is the y-intercept. So we have our U shape when we reflect it over. This is standard form, so we're going to use the formula x is equal to -b over 2a for the vertex. So we have, this is b, so we're going to use positive 12 over 2 times 3, which is 12 over 6, which is 2. So it means our vertex is going to be 2 comma something. We don't know what that is, so we're going to plug in a 2 in for x. 2 squared is 4. Multiply, so we get 12 minus 24 plus 5, which -12, so 12 minus 24 is -12, -12 plus 5 is -7. And that's a y. So we're ready to graph. We have 2, -7, 1, 2, 3, 4, 5, 6, 7. That's our vertex. And then this value right here, this 5, is our y-intercept. So 1, 2, 3, 4, 5. We have the axis of symmetry. We have half our graph, and then we're going to reflect it over. So it's going to be over 2. We're going to draw the other half. We have an x-intercept here and an x-intercept there. The y-intercept's up here. We have our graph of our parabola. So number 4 says solve, find the x-intercepts, find the roots, and find the zeros for, and it turns out it is all the same thing. Those are, yeah, so you find one set of numbers and you're good. Okay, so this is our graph. We're not going to graph it, but we can. But we will tic-tac-toe it. So we have x squared, x and x, 27. 27 is 9 times 3, but we're going to use negatives. So we multiply across and add up, we get -12x. So our answer to tic-tac-toe is, so w of x is equal to x minus 9 and, I'm going to erase that, x minus 3. Then to solve, we're going to separate and solve. So we x equals 3, x equals 9. That is all of them. So it is the x-intercept. So 1, 2, 3, 4, 5, 6, 7, 8, 9. We do have a U-shape that goes through them like that. They are the roots, they are the zeros, they are everything. So make sure you understand that. We're going to write in vertex form, which means we need to complete the square. So there's a lot of ways I've taught you how to complete the square. The formula way would be 10 divided by 2 squared is 5 squared, which is 25. And that's what C is supposed to be. So we have a 19. We don't have a 25. So this guy right here needs to be in the problem. So we're going to add 25 and then take away 25. So that this here, right here in purple, it's different color, 3 colors, this right here in purple, we can tic-tac-toe it. The reason why we're doing this is because we get 2 5s. Remember, when we complete the square or put things in vertex form, they have to be identical terms on our tic-tac-toe. So it would be x plus 5 squared. Now what's left is to take what's left here, put them together. And we have our answer. And this is t of x equals. And that's vertex form. So remember, whenever we think vertex form, a quick way to do it is put it by complete the square. There are other ways to do it that I've taught you in the class though. So here's the same question. It says solve, find the x-intercepts, find the roots, and find the zeros. And we could tic-tac-toe it, but it turns out we can't tic-tac-toe this. So what we're going to do is use the quadratic formula. Now I know every one of you memorized the quadratic formula because on the SAT you won't get it. So you have to have this memorized if you want to use it on the SAT. So you might as well memorize it now. You might as well over Thanksgiving break repeat the quadratic formula 10 times a day until you have it memorized, if that's how you got to do it. I never had to do that. I memorized it on first sight. I just fell in love with it. But anyway, so the quadratic formulas here, we have our A's, B's, and C's, and we get them from our equation here. So we have the opposite of B, so we get positive 10 plus or minus the square root of B squared minus 4 times A times C all over 2 times A. So we're going to multiply everything. So we're going to pull this over here. So we got 10 plus or minus, that's 100, and then 4 times 5 is 20 times 4 is 80, so we get 180 in the inside. If you're wondering what I did there is I put it in the calculator. So again, in the calculator I wrote parenthesis negative 10 parenthesis squared minus 4 parenthesis negative 5 parenthesis parenthesis 4 parenthesis close parenthesis enter, and it's 180. Sweet. And then we're going to simplify 180. So 180 is 36 times 5. So we get square root of 36, square root of 5 over negative 10. So we get 10 plus or minus 6 root 5 over negative 10. Now from here we could do a decimal. Right, so we could do a decimal, 6 times root 5. So 6 times the second square root of 5, I'm using my calculator here, is 13.41. We could put that in there and solve. Or we could do what the SAT does, and that is break it apart and then reduce. So 10 divided by 10 is negative 1. And then this turns into, 3/5 root 5. And there we go. All right, question number 7, simplify. We're adding here. So 5 plus 5 plus 3 is 8. And then negative 2 plus 6, negative 2i plus 6i is 4i. And this right here is a minus. So I'm going to do negative 2 minus 5 for 3. And 17i minus 15i is 2i. we have 2 of these, and then we're going to FOIL. Notice again, how do I know I'm going to FOIL? Well, because I have 2 of them and there's no plus or minus in the middle, so we know we're timesing. So we have first, outer, inner, last. We have like terms in the middle, so we get minus 12i, and I squared is negative 1. So our final answer is 9 minus 4, which is 5, minus 12i. D, we're going to be simplifying this. Again, we times by what we call the conjugate. So it'll be 2 plus 5i and 2 plus 5i. The interesting difference on this one is we're going to FOIL the top. So when we FOIL the top, first, outer, inner, last, we have 10 plus 25i plus 2i plus 5i squared. All over, and it's conjugates on the denominator, so you only need to do first and last on the conjugates. So we're going to simplify now. We have like terms in the middle here, these 2 here. So we have 10 plus 27i plus 5 to the negative 1 here because of that. And then we have a negative 1 there, which is going to make 29 on the denominator. So when I put these together, I get 5 plus 27i over 29. Again, if this was the SAT, they would break it apart. Sweet. So that's kind of our whole year in a nutshell with all different types of problems and everything. We're missing some other stuff that's also important, but you can't fit it all on one page. So hopefully you have a great day.